Hi, this is Russ Dollinger from Science Glen. I've developed a new type of ionic model. I call it the Ionic Disc Bonding Model. Something that students have a lot of trouble with is figuring out what are the right proportions. So imagine that you're making sodium fluoride. Okay, you have a sodium, it's got a plus, and we'll add a fluoride to it, and boop, it pops together. Look at that. They just stick together. See? Isn't that cool? Okay, and I have different things on different sides. Now these are just prototypes. The actual models are in production right now in China. They'll be available around the beginning of the year. Let's say on the other hand that you're making sodium hydroxide. We'll take out that fluoride and put it on hydroxide. There it is, sodium hydroxide, NaOH. Here, let me move that around a little bit so you can see it a little better. Okay. Now, on the other hand, let's say you're making something with calcium. Calcium, well, how many fluorides, well, how many hydroxides would that take? Well, it's going to take two. There's two pluses. It's going to take two minuses. So it's going to be Ca parentheses OH2. Oh, that's simple enough. Okay, now let's say on the other hand you had aluminum. You're making aluminum fluoride. Well, I'm going to have three fluorides in. Three minuses. Here's another fluoride. I need one more fluoride. There it is. Okay, so you can see. There you go. Aluminum fluoride. AlF3. Students just get it because it's kind of obvious. This works. Say you're going to make something with oxide. Well, how many cations are you going to need? How many sodium ions are you going to need? Well, you're going to need two of them. Simple enough. Boom. And another sodium. There it is. Okay, so you can see it. There. Now, let's say on the other hand that you have calcium oxide that you're making. So let me get my calcium here, and I have an oxide. Well, I can just stick it together like so. And I have calcium oxide. So if this is of interest to you guys, let me know. Thanks so much.